Welcome, this is a short presentation of our study presented in Eurobus 2022. First, we must have in mind that gas porosity is an intrinsic feature of high-pressure die casting process. Some people usually wonder why is there porosity in the casting. Let's think in that way. In the cavity, there is air, lubricant and possible some water or steam. So, in order to produce a casting with no porosity, the flow must push the air out of the mold and replace it with molten metal. The problem is that in high-pressure die casting, the aluminum is injected at high speed rate, so there is no time to let the air escape from the mold through the natural venting, either with the basic runners or with the more efficient chill vents. The conclusion is clear. Natural venting is insufficient if we want a gas-free component. The question here is if our casting have an admissible gas porosity level or not. If we want a further porosity reduction, we will need vacuum technology. Why? Because less air in the cavity before die filling will mean less porosity in our components. Thus, at Azterlan, we have developed our own vacuum technology and equipment. It is presented as an innovative solution with a sequential vacuum capable of evacuating the gases from the mold in stages, what minimizes the sucking effect of a sudden vacuum step. I would like to remark some of its features. That it is movable, it is compact, let me say that it is the size of a thermoregulator, it is robust with minimum maintenance, but it is worth mentioning also the monitoring capacity of the most critical variables of the vacuum process. All of them synchronized with the rest of variables of the injection process, what allow to check the adequate response of the vacuum system. With the same philosophy, we have developed and we have gone a step further with the ALU-V Plus, a more powerful equipment. It can combine up to 3 stages and it has capacity for bigger machines, high vacuum, what it makes suitable also for structural castings. Now I would like to look on the monitoring of airflow and the difference between the natural venting and the use of ALU-V. So in this injection curve that corresponds to a mold including the vacuum system, but in which the ALU-V was not activated, as a result we record no vacuum pressure, but there is still an airflow measurement recorded. This corresponds to the mass of air removed through the natural venting. Whereas, in this injection curve that corresponds to the same mold, but in this occasion the ALU-V was activated, we recorded a higher amount of airflow that corresponds to the difference between the mass of air removed through the vacuum comparing to the natural venting. When it comes to vacuum, the target is a certain vacuum level inside the cavity. So the question is, what is measured and where? Vacuum pressure is always measured, but usually only in the pipe. However, the reality is that vacuum in the pipe is very different from vacuum inside the cavity. That is because one of the major problems with vacuum is leakage, that come from a deficient closing surface along the parting line. So, when we cannot measure vacuum inside the cavity, airflow monitoring can give us valuable data, like leakage detection. For example, we were able to detect a leakage problem through the airflow monitoring. We record a suspicious high amount of airflow. Besides, after the die filling, the airflow remained constant, meaning that there was a leakage issue in the venting valve. The reason was the different thermal expansion between the venting valve and the die cavity steel that caused the deficient closing surface and obviously the leak. So pointing out some of the learnings, first that vacuum is essential for minimizing gas porosity as long as it is carried out correctly without no leaks. The ALU-V and ALU-V Plus are proof solutions. At Azterlan we developed the whole vacuum project, from the mold design to the setting up and finally the results analysis. Third one, monitoring is the key to guarantee a sound vacuum process. Airflow and vacuum pressure are critical variables, and airflow can shed light on molds where we cannot have a measure of vacuum inside the cavity. You can contact me or my colleagues at Azterlan Light Materials Department for further details or discussion. Thank you very much for your attention.